Okay, yeah, I guess I can hear myself now, so I'm guessing you can hear me too. Does this work?
Yeah.
Everybody hear me? Okay, awesome. So I will try to use this and not run around too much, which I usually do. Thank you so much for inviting me. I'm really happy to be here. I should say one more thing about the flight delay, or about my flight delay, is that if we had smarter machines that would have booked me so that I had more time in New York to catch my connecting flight, I would have made it yesterday as well. So it's not just about the machines that cross the Atlantic, it's also the machines that figure out how you get to a place that could be smarter, and I think we should be taking that for granted, but whatever. I made it here, so I'm very happy about that. And I want to talk a bit about how we turn data into stories. And I want to start by, because I always have this problem with people using my pictures on a website, and I didn't know how large this room would be. I figured I'd put a little picture of myself so you can see what I look like. It's also always a good way to start a talk by having a picture of a dog there, I guess. And but to talk about what I really want to talk about, I looked at this title a few weeks ago when I was starting to actually put the talk together, and I thought, I don't actually like this title. I don't really like the idea of just making this kind of general talk. I want to be a bit more specific. And what I want to talk about is another idea that I've been thinking about for the last few weeks, which is something I call presentation-only visualization techniques, which is going to be related, but it's going to be a slightly different talk. But I think this will be relevant also for what I think the people here are interested in, which is the more of the design aspects of data visualization. Now, what do I mean by that? What do I mean by presentation-only visualization techniques? What does that even mean, I guess, in terms of where visualization is? And the important thing here that I want to point out is that there is a very strong bias in the academic community, the academic visualization community. If you know the ISVIS conference or the visualization conference or EuroVis, those conferences very strongly are biased towards analysis and exploration of data. They have only started very recently to look into the presentation of data and into what we call data storytelling. I'm kind of liking that term less now because it's a bit loaded, and I'm more interested in how do we present data, how do we communicate data to people, and how do we use data to communicate with people about an issue. And I think that's also more in line with what we will be talking about here today. So presentation is a different thing than analysis, and I hope to show you a very simple example with some very boring charts. Here's a chart that I made very briefly here. We have this data set in Tableau that's called Superstore, and I just looked at sales data over time, and I use a line chart for that because it's data over time. That's what you do. And then I break it down by the different product categories. We're selling furniture and office supplies and technology, and we look at that, and we can see that there are some patterns here that sales have increased and so on. We can look at the customer segments, whether it's consumers or corporate customers or home office. We can look at things like the ship mode. How are we shipping things? And you can see that there are differences in that. And it's all, line chart after line chart. And that's what people do all the time. This is what tools like Tableau are used for all the time. Boring, simple charts. And that's very good because these are very useful charts, but they're not meant to be interesting. They're not meant to be more than that. They're just that. They're tools to let you look at data, and that's all they do. But this is very much the focus of data visualization right now, is how do you use charts that are all very similar, very interchangeable, very forgettable, and I mean that in a very literal sense, to do data analysis, because you don't need to remember this. You have the image to remember this for you, and the machine to know the data for you. You don't care about remembering this. So when you do data analysis, what you look for are techniques that usually have to fit a few criteria. I only put 3 here. There could be a few more, but I'm going to go with these 3, and I'm going to say, well, they have to fit the data. So they have to be what represents the data correctly. So the line chart for continuous data, maybe a bar chart if you had categorical data and so on. They should be effective. They should also be task appropriate. So it depends on what you're looking for. You might do different things if you're trying to rank things versus trying to compare things. And in general, oh, this is kind of weird, but so generally what we want is that the techniques should be general as well. And this is an idea that comes out of computer science, because data visualization is a field of computer graphics, and so it's coming out of computer science. And computer science likes to think in terms of algorithms that usually should be general. They should work for any data. a sorting algorithm is not going to be very useful if it doesn't work for some data, right? It has to work for all data. And that's also been an idea that we've been talking about in data visualization. But I claim that this last part, the generality, is not actually something we want for presentation. Instead, we want something else. We want our techniques to be engaging, and we want them to be memorable. So this is kind of the opposite of the forgettable ones that I just showed you. To give you an example of what this could look like, here's a bar chart. That is a bar chart of the amount of money spent on the presidential or the not sure presidential campaigns, but Senate and House campaigns actually in the United States in the 70s and early 1980s in millions of dollars. It's a bar chart that looks like all the other bar charts, and you're not going to remember it, in 2 minutes or so. So how can I make this more memorable? How can I make this more interesting for people to want to actually look at and also to remember? I can add, first of all, I can add a little description here to say that these are total House and Senate campaign expenditures in $1 million. And then I could give it a title. I could say, well, these were monstrous costs. Because the costs have been increasing, I could say, well, they're becoming monstrous. Right? But that's not very impressive. That's not very memorable. Well, maybe this one would work a little better. And this was done by Nigel Holmes in the early 1980s for Time magazine. And you can criticize this quite a bit. You can say, well, okay, there's kind of a bar chart here. The teeth of the monster represent the data. So they're like bars. But the baseline isn't straight. It's not level. There are all kinds of decorations. Edward Tufte will be all over this saying, oh, there's all kinds of chart junk here. All kinds of stuff you don't actually need for the representation of data. Like, the entire monster. That's not part of most bar charts. But that's exactly what makes this memorable and what makes it unusual. This is a very specific chart for a specific topic. There's also the clever thing here with the tail, which I can point here, the tail of the monster being a dollar sign. And it's got a little vote button here. And even the reflections, the light reflections in the little spit bubbles there are dollar signs. So there are lots of little clever little ideas in here that make this more interesting to look at and more interesting to explore than a boring old bar chart. But of course, this is not something you want to do if you're just exploring data, because A, it's way too much work, and then you don't actually need all of this stuff, and you might need more precision if you're looking at data than you can get from this kind of thing. But this is really part of a continuum that I think we need to understand more clearly. There is the boring bar chart on one end, and the very specific, boring and general, I should say, very boring and very general bar chart on one end, and there is the very specific and much more exciting, much more memorable monster here on the other end. These are just examples here. And I claim that there is a middle ground, that there are things, that are techniques and ideas we can use that work well, that work better than the basic charts, but that aren't quite as extreme perhaps, and certainly not as much work to create as the monster. And what I want to do in the next 20 minutes or so is to give you a few examples and show you what those can look like and how they are actually used right now in data journalism, and how they make for more compelling stories, if you will, and more compelling presentations of the data. I'm going to start with my favorite technique right now, which is called the connected scatter plot. Has anybody heard of that term before? Okay, a few people have. Okay, good. Well, after this, you will all know what this is. The connected scatter plot is a technique that's very simple. You take a scatter plot and you connect the points with lines. And you do that in temporal order. What I'm showing you here is an example from the New York Times from 2012 that shows car fatalities versus miles driven. So what you see here on the vertical axis, so on the vertical axis here, you have car fatalities per 100,000 people, and on the horizontal axis, you have the number of miles driven per capita, I believe. So this is also somehow normalized. And the data starts in 1950 here, so 1950 is the first data point, and then we go 1951, 52, and so on. And as we go through time, you can see that there is a pattern emerging, and it keeps going and going, and you can see things that are unusual. You can see that it starts doing this thing where the line kind of goes back on itself. It starts to make a loop. And you start wondering, wait, how does it even work? How do you get a loop in a line chart? Until you remember that time isn't actually on the x-axis. The x-axis is number of miles driven. Time is along the line. So you get this story essentially or this road trip in a way, where you walk or you drive along this line. And when the number of miles driven decreases, you can get a loop. So you can have the number of miles as the number of car fatalities in this case was decreasing. Number of miles driven was increasing. So increasing is going up. So we have the number of fatalities increasing here for a while, the number of miles decreasing, and so we kind of get this loop. And then as the number of miles decreases, the number of fatalities also is decreasing, and so then we get the part where it kind of drops down like this. And you can also see certain parts of this chart that have different kinds of patterns, different kinds of directions. If you think about it, and if I hadn't shown you this in the beginning, if I just asked you what do you expect as the number of miles driven increases, what would happen? The number of accidents would also, the number of car fatalities would also increase. So what you would expect here is you would expect to see a line starting in the lower left here, which is lower values, and going to the upper right. But that's not what actually is happening. You can see that sometimes, during some parts of this, that is actually true, that there are parts where the number of fatalities is actually increasing fairly steadily and very quickly, but then it's leveling off. And then it's even decreasing, it's dropping down over here. But this makes for a much more interesting exploration, a much more interesting representation of the data than a simple scatterplot certainly would, because a scatterplot would be fairly sparse and very boring. And you can do things here, like this very clever example here actually uses annotations. If you're looking at these little annotations here, they use little sparkliney things where they show the entire chart as a gray line, and then they highlight the part of the chart that they're talking about. Like here, the energy crisis in the 1970s, and then further down, seatbelt laws and so on, and laws about drunk driving and so on that changed the number of fatalities and changed the shape of that chart. And the whole thing makes for a very compelling layout as well. So this is part of a whole page that shows that story, and it has some text and then some annotations around it that tell you the story of what things happen. Now, I should say that this technique is really interesting and it's really useful in some cases, but it's also very difficult because it's a technique that is, as I was trying to say earlier, not a very general technique. So when I tried this on slightly different data, I got this, which is not nearly as pretty, and it's kind of confusing because there are lines on these lines kind of going over themselves and so on. This is looking at debt versus minimum wage here. I have a whole series of charts that looked at minimum wage, how the minimum wage has changed over time and so on, how real incomes have changed, and this is part of that. And then when you look at more data like this, you can look at something like this, and you're like, okay, wait, this is interesting, but also kind of hard to read. And sometimes you end up with things like this, which are essentially a hairball. I forget what this even is. This is the unemployment versus the participation rate, I think, in the US for all the different states over a long time, because I just got the data, so I figured I'd try this. And so the interesting thing is that this technique actually does not work in most cases. I would claim that in about 95% of cases, this technique will not work. It will not give you a useful chart. It will not be an insightful, useful tool. But when it works well. But that means that the general idea, or this idea of generality, is no longer applicable, because we can no longer say, well, this is a good technique because it's going to work in most cases. It's going to give you a result like a scatterplot would, or a line chart would, or a bar chart would. So it's a very different kind of animal. But I want to make sure that I don't leave you with the impression that this is useless, because it has worked really well in many cases, and I want to show you a few more of those. Here's an example from Popular Science from a few years ago that was looking at the helium supply in the US. It looks at the price of helium and the amount of helium that was present at that time in the different helium stores that the US has. And it gives you an interesting little shape. And you can see, again, these annotations that tell you about different times when there was different legislation, for example, that changed how the helium, how you could access the helium and so on, and how kind of things, just happen over time, and how there are these loops here that tell you something about how the patterns change and how the patterns, or the two time series that you're effectively comparing, how they are behaving relative to each other. And one of them is maybe ahead a bit than the other one, and then you get this kind of loop shape. Here's another one that's not going to work as well without the animation that goes with it, but that's still going to be interesting, I think, because it's fairly complex, but it still works because they're doing a sort of clustering here. This is about the essentially the origin of this technique. So I didn't talk about this very much here, but the idea actually comes out of the economics literature. There's something that's called the UV curve, or the I forget the actual name of the person. The Phillips curve. That's right, Phillips curve. There's actually another term for it too that I'm blanking on right now. But this is a term that comes out of a comparison of unemployment rate versus, I think, the participation rate, or long-term versus short-term. But this is long-term versus short-term unemployment rate in the U.S. And there is an argument about what's called the natural unemployment rate, and it's a long argument about how it's been shifting and so on that I don't even understand. But the point is that what they were trying to show here is essentially data. This is monthly data over about 10 years or so. And it's fairly complex. If you just look at this, you're like, okay, this is not a useful chart because there's just too much going on. There's too much clutter. But what they then did was they had 3 different colors, and there's actually an online version of this where you can mouse over the bubbles in the middle, and it'll highlight just that part. And these clusters actually work pretty well because they give it this shape here that kind of outlines the overall shape, and then they put a little scorpion on top because it looks like the tail of a scorpion. And so it's called the scorpion chart. And the idea is that this is not something you're going to remember. So I remember the chart shape of this because I remember it was called the scorpion chart. And I remember that this is roughly what the shape was. And I remember that this is roughly what the values are in succession. So it starts on the top left there and then goes around. We are a very fast growing company. So if you're interested in that, most of the positions, and this is across the board, sales support, marketing, design, we have a kick-ass UX design team, we have researchers, we have developers, everything you can imagine. We're looking for those kinds of people across everything. So if you're interested, go to this website. There's lots of hurrah, this is so awesome stuff, and then there's an actual link that lists all the things that you can apply for. But if you're interested, come talk to me. I'm happy to tell you more about the company. It's an awesome company to work for. So very happy to gush about it. And then with that, I'm happy to take any questions if there are any.
Okay, we have one here. We'll go second.
That was a lovely presentation. I really enjoyed it. I wanted to comment on your connected scatter plots. Mm-hmm. And so it's not just a question of memory. When we're looking at graphics, it's inferences. What conclusions do we come to? And it's not just associations. We have visual ways of interpreting information. And because time on the horizontal is such a strong visual clue to understanding, when you violate time, it takes us a long time to comprehend. And so I think you're right, those are great graphics for presentation, but presentation when I have time to look at them and read them and study them.
Yeah.
So that they don't work as well, say, in this kind of presentation, because I need to, I need to study them, and I need to understand why time is being violated in this way and what the meaning is there.
Yeah, that's a very good point. And there's also two brief things to say to that. that's actually part of what people usually want you to do. They want you to spend time on this. This is not to be efficient. This is about drawing you in and actually having you pay attention to it and really spending time on this. I think this is part of making something unusual. And the other thing is about the time axis, that actually all of the ones I've seen that have been published roughly follow left to right in terms of what time is. So the idea is that time could start anywhere, and it could go right to left, but again, this is all US media, so the usual reading order is left to right, and so most of these have the lower values and essentially look like time axes left to right. I have one example, which I didn't put into this presentation, that goes the other way, and that's actually hard to read because of that. but yeah, I totally agree. So you want to have the time axis roughly correspond, or the horizontal axis roughly correspond to time, which in this case works because number of miles is increasing roughly over time. But then you still get the little loops. And that is even true for this one, for example, which has this very interesting shape where it's going left to right overall, but it takes some detours along the way.
And because nothing is anchored, that also makes it hard to read.
Right.
I don't know how to read the vertical.
Right.
Because it's not anchored. So again, it takes study. And I agree, it's engaging and pretty, but it takes me a long time to understand.
Right. And we've actually done some studies that this is currently under review. So we hopefully get a paper published very soon on this that where we actually studied this, and we found that people did pretty well with it. But good points. Totally agree. Yeah. Yes.
Test?
Yes.
Fantastic presentation.
Thank you.
So one of the worst things about our profession is the effort reward curve. This connected scatter plot was a great example because I can't count the number of times that I've been excited about telling a story a certain way I have in my head. This is how it could look, and then I put in all the effort to develop it. And then I put in the data and I get back a hairball, and that's a shitty feeling to have spent all that time. So my question about this, particularly in the context of when you're designing presentations, not for analysis but for visualizations for a presentation, what approaches or what ideas or thoughts do you have on approaches for mitigating that risk, for getting an early escape hatch? And knowing this is going to be a hairball, I should cut and run now, or I don't know, how do you approach that? Because this is something that I struggle with daily, and I'm curious to hear your opinion.
Well, so the first thing I would say, start with the data. So don't design something and then put the data in at the very end, because it's going to be terrible. So you want to start with the actual data or something that's close to the actual data. So you don't end up trying to do something and then end up with this, right? So that's the big risk. I have some work that I've done that isn't published yet, and I don't know when this is going to happen, but I have some metrics to figure out when you will get this versus that. So you can tell from the data. There are some obvious ways. You can count loops, you can look at angles and so on. So you can figure out whether a data set will work well for a particular technique, at least for specific techniques when you develop the metrics for it, or the measures perhaps. So that can be done, but that's not something that's very practical right now. I would say start with an exploratory tool. Speaking as a Tableau representative here, that would be one. And by the way, any students, you can get a free license of Tableau through the student program. So if you go to the website, there is a link somewhere. It's pretty well hidden, but there's an academic program. You can get a free license for a year, and they can renew that as long as you're a student. But so that's a way of doing this. So you can just try out, and you can do these in Tableau. So this was done in Tableau, and you can then just try it out and see, oh, this doesn't work, and then try another one. Do something else. Do a bar chart. Do this or that, and you can also build things that are fairly complex, even in a tool like that, or even in Excel, whatever it is. You can build things that are much more complex than you would think, because you can play with those things. You can do all sorts of mappings by just stacking things and so on. So you can develop that way, or you can do something. My background is computer science, so I think in terms of code, you can use D3, you can use processing, you can use some of those things that are very lightweight, where you can do things quickly. They don't have to be well developed, but just to kind of get a sense of the layout and of what things will look like, and then you have a certain idea of whether it's going to work or not, and then you go from there. So I would start. That's basically my main point, though, is to say start with the data, not assume that the data is going to work out, because that's very risky.
Many thanks for your lecture. 2 points
Thank
I
you.
want to raise. Basically, you suggest that visualization, good visualization, is a strategic compromise. But can you talk a little bit what distinguishes between legitimate compromises and illegitimate compromises? And this is one thing. And another thing, I like the chart you showed about mortality of accidents. As another thing, it is, in order to present data this way, you need a lot of subject matter expertise. You need to know the story.
Yeah.
You need, and this has to be a very professional and authoritative story that you want to tell. Can you talk a little bit about this component of subject matter expertise that is needed in order for a successful presentation?
Certainly. So those are really good questions, both of them, and I could spend a lot of time on them, but I'm going to try and just briefly talk. So the first one was about the compromise between representation, I guess, and making it interesting versus being following, I guess, the usual visualization rules. And that's interesting because sometimes, and I don't have an example, I think, here. Well, maybe this one works. So this is an example that there are things here that you should not do, right? So the baseline should not be curved like this. It should be level. So there are two things that are basically wrong. Here it's not level, and it's not straight. And the bars should be, so the lines, all of these lines, including the scales, are all curved, which is bad, right? So this is clearly a compromise. But I think the point here was not the precision. This is not about, is it 248 million or is it 249 million? Who cares? It's not about that. It's about the numbers have been increasing, and they have been increasing fast. That's the point. And then they're large numbers. This is 1980s dollars, so this is actually a lot of money. But that's what they were trying. What Nigel Holmes was trying to show here. So this is clearly a compromise, and depending on where you see the relative priorities or the relative importance of the different things, you will go one way or the other here, because you will say, well, it's more important to attract people's attention and have them read this and realize that this is going on. Or you can say, well, no, it's important that they read the exact numbers and they don't see something that's bad, that they should not do. And I think in this case it's done well, because it's still reasonably close and good, but it's not. But yeah, it's certainly that's why I was trying to say. Well, there's this continuum here, and this is certainly the outer end of that. What I think is still reasonable. I mean, or close to reasonable. And you can err, and it's going to be different in all those cases. So it very much depends on what you're trying to achieve and what you're prepared to give up for that. There are examples, and people are arguing that sometimes you can use, for example, when you have categorical data, you're not supposed to connect the categories with lines. But in some cases, that can still be useful, because you might actually see some things with those lines. But you have to be careful. You have to know that the ordering is going to be important, and which ones are neighboring, is going to make a big difference. So you have to choose those wisely. But you can choose them to make a point, and if that works, then it can work. But yeah, so it's hard. It depends very much on the different in each case. And the other question was about the background knowledge, and that, of course, that's what this is all about. So this was done. I know that Hannah Fairfield, who created this, did a story. She was working on a story about car safety, and that's how this came about. So she knew all of that. She was researching this topic, and of course, you have to know a lot about the data. If you just start with numbers and you don't know a lot about them, it's dangerous, because then you start making inferences that might not be correct. And so you have to then talk to experts. You have to talk to people who know what this actually means. And so I totally agree with that. So you want to make sure that your interpretation of the data is correct. Yes. But many times what you're trying to do is you're trying to get something across that you know something about. It's not just numbers, but it's numbers that you know about, where you have a story around that or an intent around them. And so you definitely want to have that. I agree with that. But that's in the journalism case, I'm kind of assuming that that's true. It may not always be true. And sometimes, of course, you can also bias things. If you're trying to do this for advocacy, you might be going overboard a bit. So you have to be careful not to do that. But yeah, obviously you need to have the knowledge, and you have to. And if you don't have it, you have to make sure that you can find it somewhere. You can find the person to talk to, or you can do the research. But yeah, good questions. Yes, Enrico.
Test. Okay. Hi, Robert.
Enrico.
So I think you raised a really interesting point when you say that distinguishing what is specific to presentation-oriented visualization versus analysis. And if I understand well, two main important points there are that we need to be able to engage people in the first place so that at least there is a chance that they will read the chart. And then after interacting with the chart, they have to remember the chart, right?
Right.
But I'm wondering if you can spend a little bit more words about what happens in between. And in my opinion, at least to some extent, so readers need to be able to unpack the information that is in the chart. So being able to read this information and then to memorize this information, not just the chart, right? And so I'm just curious about what's your opinion about this problem, because I think in general it is possible, at least in principle, and I guess it is happening in reality, that some charts do engage people. They actually are memorable, but not necessarily lead to knowledge transfer. So do you think that knowledge transfer is important, always needed, only sometimes, under what conditions?
So I think I definitely want to have. So there are different levels, I guess, of knowledge. One thing is you actually remember like the details of the chart, or even what the chart looked like, which isn't necessarily what you care about. You care about people understanding the overall point and taking that away. And then you said something about what happens in between. So this is also to Barbara's question about the difficulty. So these techniques are unusual, they're unfamiliar. And that's actually, I think, a strength in many cases, because you end up with things that people hopefully will want to actually figure out. And that's why there are these annotations there in this case, because they tell you something about how to read this, how to actually understand this. It's not just here's a chart that you've never seen before and we won't tell you, because that obviously would be a bad thing. So the in-between part is you have to study it, you have to look at it, you have to read the little annotations here, and it walks you through. There are other examples that use scatter plots and just point things out on a scatter plot without connections and just tell you what this means, what that means, why there's an outlier here, and so on, and then label certain things and then tell you something about that in the context of that. So they give you what Amanda Cox of the New York Times calls the annotation layer, which is a layer on top of the actual chart that gives you the actual information about what the things are that you're seeing and how to read it. So that's kind of the point of what happens in between. But then also, what do you want people to take away? I think in this case is that it's complicated and that there isn't just one thing that happened. But what I remember about this chart always is the loop, and I remember the oil crisis. And from that I can kind of reconstruct the rest. So I've seen this, I've stared at this chart for way too long, but it's just a chart something that I can latch onto and I remember. And then once I have a point of connection, I can then remember the rest and remember roughly the shape of it and remember roughly what the times were. And so I have a sense of what happened when. There are other ones, again, to get back to the monster. Here, the point is to remember the increase, or perhaps to just remember the fact that costs are increasing and that they're monstrous. Even if you don't care about the increase part. And this was studied as part of this first study on that topic in 2010 or 11 by some folks from the University of Saskatchewan, and they found that people remembered this chart much better than the bar chart, which isn't surprising. But they asked them different questions. They asked about the chart itself. They also asked about what's the message, and people remembered the message really well. So I think what you want, which is I think the title is what they wanted as the message, I guess. But that's what you care about. You want people to take something away. If they remember a lot of detail, that's good, but it's very unlikely. If they at least remember some of it, then that's at least better than nothing. So that's the same thing for my presentation here. So if you remember this chart, then I've done my job, because you've seen something that you probably haven't seen before, and that might give you something to think about. If you remember a few more things, like my jokes about Minar, then that's helpful too, because that's stuff that you've already seen, most of you had seen before. So I'm kind of lowballing this. I'm happy if you remember 2 or 3 bits of information from this talk. If you remember everything I said, then that's probably not good, because I said lots of stupid things too. But trying to kind of get the right level, hoping that you remember as much as possible. That's kind of what I'm trying to get to. But yeah, you're right that there's a good question. We don't have a metric. We don't know what we should ask for exactly, and that's something we need to figure out. But that's because we're still very early in this. So when we're talking about storytelling, we're talking about data presentation. That still is something that's only been something that people actually kind of have accepting in the field, or have accepting for a few years now. It hasn't been very long, and there has been a lot of criticism of this study, of the Saskatchewan study, and then also some of the follow-up work. So it's going to be a few more years before we actually really can treat presentation and storytelling as a full part of data visualization research. And hopefully by then we'll have a better understanding of what questions to ask, what the metrics are to use, and so on.
Thank you very much. It was great.
Thank you.